Hi everyone. Today we'll learn about bearings, including measuring bearings, drawing bearings, and calculating bearings. So let's get started. So to begin with, have you seen these directions? Yes, you must have learned these directions in your geography. Okay. Now these are known as bearing in geography and maths, which means a way of describing and using angles. Can you see the connection between two subjects? Now, there are certain rules when doing the bearings. The first one is they're always measured from the north. So 0 degrees to 360 degrees. You cannot leave it as a 0 degrees. Second rule says that bearing should always be measured into one direction, and that direction is always known as clockwise direction. Okay? And the third rule says bearing should always be written in three figures only. If they are not in three figures, they are not bearing. So if it is written 0 degree, it should always be written as in bearing. If you're answering a question of a bearing, it should be written as 0, 0, 0 degrees. Likewise, if it is 82 degrees, it should be written as 082 degrees. If you don't give your answer in three figures, you will lose your marks. So be very careful. Now, who uses bearings actually? You should know that as well. So bearings are usually used by the sailors, also used by the pilots when they have to describe the direction they are traveling in, and they are also used on land by the hikers and the military. So you know how bearings can be used and how important they are. So after learning the rules of the bearing and the directions, you also need to learn the types of angles. So here are some angles which I'm showing on the screen. I would like you all to pause the video and try it by yourself by naming these angles and the estimated size of these angles plus the definition of these angles. Give it a pause and try it by yourself. So here are the answers for you all to see how many of you were right while answering the question about the types of the angles. So after learning the bearing rules and the types of angles, it's time to learn certain things about the scales. So you must have noticed some of them around you, like your house, pencil case, shops, etc. Like these kind of scales. But some of them you must have seen only on the maps when you're analyzing the graphs, either in your science classes or while doing any type of experiments. So these are known as scales as well. Now, while working in this topic, we will follow the scale which we use on the maps, which shows like these, okay, where you can find that somewhere on the map it must have written that 1 centimeter or 2 centimeter on the map is showing 200,000 kilometers on the actual ground. So to do any question related to bearing and scales, we need these two equipments. Which are those? A protector and a scale. Without these two, you won't be able to answer these questions and you will lose marks. So they are very important. So here are some worked examples. My question 1 is, I have been given 2 points and a line, and the question says work out the bearing of A from B. Now first thing first is locate the point you are calculating the bearing from. So in this case, we have a point B, which is our point of calculation. Okay. Now in this case, I have been given a part of equation which says that my part of angle A's bearing is 056 degrees. So in that case, I'll make my north line, and from the north line, I'll make a straight line, and I can see that angle on a straight line add up to 180 degrees. So if angle on a straight line add up to 180 degrees and 180 degree plus 056 degrees will give me 236 degrees. So this is how I'll find my bearing of A from B, and I'll write it in three figures. Okay, so this is how I will always answer the question. But remember, I have not gone anti-clockwise, I've gone clockwise. So I'm still following the rule of bearing, which we have mentioned or we have learnt in the start of our lesson. Now my second question is the bearing of P from A is 075 degrees. Calculate the bearing of A from P. So here's the diagram given to us. So my angle A is 0.75 degrees and I need to see my bearing of A from point P. So I have already located my point P as a point of finding the bearing. Here I'll make my north line, and along with it I need to find out some more hint here. So in that case I'll just extend my AP line and can find that my angle A and angle P are looking like a corresponding angles. And when I talk about the corresponding angles on a parallel lines, they are always equal. Okay, so if A is 0.75 degrees, my P will be 0.75 degrees as well. Now I have a part of my bearing and the second part will be my 180 degrees. Following the same rule, angle on a straight line add up to 180 degrees. If I add both of them, I'll get the answer as 255 degrees. And this is how I'm going to write my bearing of A from P in 3 figures. Here's another example for us to try. Okay, so this is the example. Now question is asking me that work out the real distance between the two friends' house. So real distance means the distance on the ground. So if 1 centimeter represents 3 kilometer as per the scale given to us, what I'm going to do here is I first write it down the scale and then see that the distance given on this paper or in diagram is 7 centimeter. Okay, so it means 1 times 7 is 7. Okay, so I'll not just times 7 one side but both the sides. So 3 times 7 will be 21 kilometer. And this is how I'll find the real distance between Leckert and Pfau's house on the actual ground. Now question number 2 says measure the bearing of Pfau from Leckert. Now this is a very simple question. In this I'll just use my protector, put it on, find out the angle, put it on this diagram, and then just try to find out the bearing or the angle. So it is on 110 degrees. Okay, and I just simply write 110 degrees as a bearing of Pfau from Leckert. Now third question says that another friend Stephen is 9 kilometers away from Pfau on the bearing of 0.35 degrees. So first thing is I'll find my bearing, which is 0.35 degrees. After that I'll do my calculation. How I'm going to do it? Following the same formula, 1 centimeter is equal to 3 kilometers. So if Stephen is 9 kilometers away from Pfau, it means 3 times 3 is 9. Okay, so similarly I'm going to times 3 both the sides. So 1 times 3 is 3 centimeter. 3 centimeter shows 9 kilometers on the actual ground. And I have to show it on a diagram as well. Now my another question in the same thing, it says that on the diagram mark the position of Stephen with a cross X and label it X. So wherever you are finishing your 3 centimeter, mark it as a X and then label it as S. And this is how you need to answer these questions. So after learning the rules, types of angles and the scales, there are learning checklists for you. So you have learned now how to measure the line segment, angles in geometric figures, including interpreting maps and scale drawings and using the bearings. Now, though you have learned certain things, whereas there are certain misconceptions which normally students make while answering the question about the bearing. What are those? Not giving bearing less than 100 degrees in 3 figures. That is a most common mistake which students make, where if the answer is 45 degrees, you should have written 0.45 degrees. Otherwise, though your answer is correct, but in bearing you won't get the marks. And the second one is using the anti-clockwise angle as a bearing. So for example, the bearing of B from A is 0.80 degrees. A common mistake would be if they start using the information from the angles in parallel lines, where they say the interior angles of the co-interior angle will be 180 degree. So they go backside. Now angle A, if you have to find the bearing of A from B, it will calculate as 100 degrees when you are going anti-clockwise. Whereas if you go clockwise, the bearing of A, okay, from B should be 260 degrees. Now you understand why going clockwise is always better rather than going anti-clockwise. Hope you guys liked the video and learned something new. Thank you for watching and stay tuned for the next topic, which is circle theorem. Thank you and goodbye.